Hello, everyone, and thank you for joining us this morning for our loop-powered versus line-powered choosing between digital panel meters webinar. We're going to go ahead and get started today. Before we do, I thought that I would answer a few questions I always get right at the beginning. The most asked question I have is, am I going to be able to get a copy of these slides and of the webinar itself? And the answer to that question is, of course, yes. I would suspect that mid-next week you will be getting an email, and that email will go to everyone who registered for today's webinar, and it's going to contain both a copy of the slides in PDF as well as a recording of today's webinar. Also, you may have noticed that you are all in listen-only mode. With the number of people we have in attendance here, it would just be too difficult to have everyone on with open phone lines. However, if you have questions or you want any clarification on anything, I would encourage you to type that into your chat box. It's usually in the lower left of your screen. Some of you have already done that earlier when I did my mic check, but for those of you who have recently joined us, you can chat and those messages will go directly to me, and I'll pause during the webinar if we get some good questions and give some answers to those. Finally, there is a survey at the end of the webinar, and I would greatly appreciate it if you would fill that out. It should only take you about a minute, and it'll let us know how we've been doing, and maybe even give us some insight into what kind of webinars you'd like to see from Precision Digital in the future. That all having been said, let's go ahead and get started. So I'm your presenter today. My name is Joe Ryan. I'm the VP of Sales and Marketing here at Precision Digital, and my contact info will be up on the screen at the end if you have any questions that you want to follow up with. And we're here today to talk about choosing between loop-powered and line-powered panel meters. And you can almost expand that out to cover any kind of 2-wire versus 4-wire, or loop-powered versus line-powered product. So what you're going to learn here today is hopefully an understanding of loop and line-powered meters, what they actually mean, how they work, the differences between a loop-powered and line-powered meter, how you should go about choosing the best meter for your application, and we'll spend a few minutes at the end looking at the unique features of our new loop leader panel meters, which are loop-powered meters with a whole suite of features that you likely have never seen before on a 2-wire or loop-powered meter. Now, there are a few questions I'm about to ask in a quick survey just to help me plan future webinars as well as shape the webinar that we're going to be seeing here today. And so my first question is, where are you located? We're here in Hopkinton, Massachusetts on the east coast of the U.S., so for us it's 9 o'clock in the morning, and I just wanted to know where you're located so I can try to figure out what webinar times work best for people in different parts of the country or world. And it looks like the majority of us are in the eastern U.S. or Canada, so there are a few of you early birds here from the central or western U.S. If you happen to be in other, please feel free to chat that information to me. I'd be interested in knowing where you're from. The next question I've got here is, what industry are you in? Are you an industrial distributor? Or are you in a particular kind of manufacturing environment or end-user environment? Perhaps you're a consulting engineer. You could even be in research or education. This will help me steer the discussion to make sure I'm covering the topics that are most important to you, so I appreciate you jumping in and giving us that answer. And it looks like the majority of us here today are industrial distributors with some consulting engineering folks as well. So we'll try to make sure we cover topics that are important to you. And then my last question here is, what is your level of experience with 4 to 20 milliamp loops? And this is going to help me know how into detail I need to get about what loop power meters really are and why they're important in these applications. Maybe you're a full-blown expert, maybe you've never touched one, or my guess is going to be that most of us know just enough to get the job done. That is usually how this question goes. Meantime, looking down the list of the others as far as who's in attendance, I think the farthest away we have somebody joining us today is from Japan. So thank you for letting me know that. That's always fascinating. All right, so we will cover a little bit of the basics of loop-powered meters and 4 to 20 loops, but we won't spend too much time on that, just to do a quick refresher. So we're going to start with understanding loop and line-powered meters. And first, to understand what a loop-powered meter is, we've got to know what loop we're talking about. So briefly, let me just explain that. When we say a loop, we mean a current loop. And specifically when we're talking about instrumentation, panel meters, transmitters, etc., you're usually talking a 4 to 20 milliamp loop. And the idea of that loop is that you're going to have some kind of voltage supply. In this case, we've got this V total being provided by what could be here a battery or some kind of a DC power supply. It doesn't have to be on site. It could be a 24-volt rail, for example, if it gets run out to your application location, or it could be right from a DIN rail mounted power supply, or even part of your panel meter in the case of a ProView. And that 24-volt power supply, although it could be 12, 36, usually the 24 volts, that provides the voltage needed to drive current around this loop. And I'm sure we all know that you've got a wire current to be in a loop. You've always got to have it coming back into your voltage supply. And that current's going to be the same everywhere in the loop. That current is what we talk about here when we say I. And so the idea is that you've got your voltage supply driving the current, and what determines what that current is essentially these resistances in the loop. Now here, we have a very simple circuit, so we're just showing resistors. However, understand that these are really models for whatever might be in your loop. So in the practical world, this simple voltage loop, this simple current loop could be, for example, a 24-volt DIN rail power supply. Then you've got your level transmitter up on top of a tank. And then you could have, say, your digital panel meter that's reading that current. It goes off through the analog input on a PLC and then back to your voltage power supply. And so when we say loop power meter, no, that's the loop we're talking about. And what we mean by that, we'll sort of get into right now, which is it gets the power it needs to function from that 4 to 20 milliamp loop. So if you look at the diagram here on your left, here we've got our 24-volt power supply, or our DC power supply. It's going to be the voltage that's driving the current through this transmitter, then through our panel meter, through that analog input on a PLC, and then back into that DC power supply. And in this case, looking at, for example, let's say just the panel meter, those are the only two wires that come into this panel meter. This milliamp input wire and this milliamp output wire. All of the power that that loop leader panel meter needs to run, it gets by dropping a few volts on that loop. And so you have no other connections that are necessary unless you're going to get a version with open collector or relay outputs or 4 to 20 milliamp output. No other wires are necessary. Now compare that to a line power meter, or sometimes called a 4-wire meter. Those are terms you may also be familiar with. You'll understand in a minute why this is 4-wire, and over here we call this 2-wire. It's obviously called 2-wire because, again, you've just got 2 wires that need to connect to this meter in order for it to function. In the 4-wire meter, like our ProView panel meter here, you've got 2 wires that are necessary to power it. Now, that could be 120 volts AC. That could be, there are other versions of this that would be powered from its own 24-volt power supply. But it needs 2 wires just to supply power. And that's going to be isolated from the 4 to 20 milliamp transmitter side of this equation. So you've got 2 wires over here. And then, of course, you're going to have 2 wires that are running your 4 to 20 milliamp current loop on the transmitter side, which is the input to the ProView, what you scale to see your process variable. Now, in this case, you'll see there is no power supply, and that's because the ProView is capable of providing the 24-volt output to drive this current loop. So the ProView will drive that current out through the transmitter, in this case through the PLC's input, and then back into the power supply and the milliamp input on the ProView. So on that diagram on the right, why do we call that 4 wires? Because we've got 2 wires for our power, and we've got 2 wires for our signal input. Now, why do we do those things? Well, we're going to talk about that in a second, but for me to make sure this is most applicable to the people we have here in the audience, I'd really like to know what kind of applications it is that you deal with most regularly. Are you doing pump control with these, level monitoring, flow? Do you connect them up to temperature transmitters, pressure transmitters, etc.? just so I can use some examples like the level transmitter I mentioned earlier that apply to those folks who are here in the audience. It looks like level is by far taking the lead, which again is not a big surprise. That is probably Precision Digital's #1 application that we see, followed closely by flow and pump control. Of course, pump control also has to do with level. So we'll stick mostly to level applications, but we'll throw a few more in there as we go. So now that we know what a 2-wire or loop-powered meter is, and we know what a 4-wire or line-powered meter is, why would you want to choose one over the other? What are the differences that have you make that decision? Well, there's a couple of them here, and so you can see here we've got a chart. And let's briefly just walk through this one, starting with display type. So as you may have noticed earlier, the loop leader example is an LCD meter, a liquid crystal display. And that is a great outdoor meter because you've got the dark digits, you've got that light gray background, and the brighter your ambient light, the easier it's going to be for you to see that distinction in contrast. However, without a backlight, these loop power meters don't generate any light of their own. So in dimly lit conditions, or even if you have a backlight at low milliamp conditions, it may be tough to read those in dim lights. Now, your line power meter has lots of power. That is the concept you're going to see throughout this chart. Your line power meter has tons of power available to it, whereas your loop power meter is just running off a few volts drop on that 4 to 20 loop. So your line power meter has all the power it needs to drive really bright LEDs. You can see them from farther away. They don't have viewing angle issues like LCDs sometimes have, and they're generally easier for people to read in any lighting condition. So if you want something that's viewable in direct sunlight with a sunlight readable ProView and at night with that same device, well, a line power meter is a great way to go. If you've got nice ambient lighting conditions, or if you're not concerned about it being read in dim lighting conditions, then the LCD is a nice high contrast display and you're not going to have to worry about it. The display characters is also an interesting comparison because on an LCD, we can make custom characters that have very small segments that make them up, whereas on an LED, there's a limit to how small you can make the indicators. It's tough to cram more of them in there. And so on the LCD displays, on the loop-powered meters, you've got 14 segments. And you can see here we compare tank 1 in both examples. In the LCD meter, on the loop-powered meter, you can get segments that show you capital T's really well, that show you a K that's very legible, versus the usually 7-segment display you're going to get on a line-powered meter because it's an LED display. And that's when you start having difficulty trying to read what's being displayed. You can't do uppercase letters quite right. The M's and K's don't show up well. And so you get a better display on the LCD when it comes to legibility. Cost is a big factor. Loop-powered meters are generally less expensive than their line-powered counterparts. The loop-powered meter doesn't have a big expensive power supply with transformers, et cetera, in there, whereas the line-powered meter does. So that line-powered meter is just going to cost more than its loop-powered counterpart. And of course, one big reason people use these is the installation ease of a 2-wire or loop-powered meter. You've only got 2 wires to install the loop-powered meter. In addition to not having to run 4 wires to connect, you also don't need a local power supply. Because it gets its power from that 4 to 20 milliamp loop, you can install a loop-powered meter anywhere where that 4 to 20 signal is running. So if you have an existing application, for example, and you're running it from a transmitter out to the control room, and you want to have a display, say, next to the tank for the operators in the field, well, you don't need to bring power out there. You don't even have to worry about how you're going to power this thing. You just add your 2-wire meter right in the loop. A line power meter, obviously now you've got signal and power connections. And oftentimes you're going to have more outputs on line power meters that make installation and wiring up a little more complex as well. Now, what the loop power meter can't do is provide power to run that loop, whereas the 4-wire meter can. If you refer to that earlier example, in this example, you need an external DC power supply to run that loop power meter 4 to 20 milliamp loop, whereas the ProView provides the power in order to run that transmitter loop itself. So if you have 120 volts and you want to get 24 volts out to run your transmitter loop, well, the ProView will do that for you, whereas you're going to need a separate power supply of some kind in order to run the loop on the 2-wire side. If you're looking for outputs in general, though specifically relays, most loop-powered meters don't have the ability to have relays. They have open collector or transistor outputs, which are great for low signal triggering, like sending a message to a PLC, but not great for driving external relays. Now, I will say our new loop-powered meter, the loop leader, does have relays on it. It's got solid-state relays despite being a loop-powered meter, which is pretty unique. But in general, with loop-powered meters, you won't see that kind of a relay output. On the flip side, serial communications, a more complicated kind of output. You also can't get those on loop-powered meters. However, you can on line-powered meters because they have access to the power needed to run, for example, an RS-485 signal with Modbus. Now, I know we've got a couple of questions here. For those of you who are not going to have your questions addressed, I do apologize. Sometimes it's just too complicated to get into here, but we will follow up with you to get you answers to those questions. And one of the great questions I see here from Joe is he wants to know if adding a loop-powered meter affects what the PLC sees in that example that I gave earlier. So if you'll allow me to jump back to that for a minute. So in this example, we've got our DC power supply running our 4 to 20 milliamp loop. And let's say this was an existing application, and that really what I originally just had my transmitter tied to my PLC, and then I broke that wire. I added in a loop-powered meter later. The question is, does that have any impact on this loop? Well, so long as my DC supply, which in this case I've been using 24 volts, so long as that 24 volt supply provides enough voltage to run the transmitter, the loop leader, and the PLC's voltage drop, then the current through this loop is going to be the same everywhere in the loop, and it's not going to matter if I add more voltage drops or more devices to that loop. So adding in the loop leader should have no impact on what the PLC is seeing or what the transmitter is transmitting. Now, Frank, I know that you also asked a question about voltage drops, so let me explain what I meant there. So I had mentioned that I had a 24 volt supply here. Every 2-wire device in this loop is going to have to drop a little voltage in order to have the power it needs to run. Now, in the case of our loop leader, we've designed it to have a very low voltage drop of 1.5 volts. So I've got 24 volts to work with, and my loop leader is only going to drop 1.5. However, there's potentially other loop-powered meters in this loop which could be causing the additional voltage drop. So for example, I may have a 2-wire transmitter here. So if I've got a 2-wire level transmitter, it could drop, let's say, 18 volts. Now usually PLCs are not loop powered, and a non-loop powered device is only going to drop something like 1/10 of a volt, for example. So those are generally not really a concern. Now in this case, I've got 18 volts plus my 1.5 volts plus some tiny amount for my PLC. So I'm under 20 volts in total voltage drop, and I'm driving it with a 24 volt supply. So I have not only enough voltage to run the loop, I have plenty of overhead as well. I've got almost 20%, 15% overhead before I reach my 24 volt max. So I have plenty of voltage to run this. However, it's important to keep in mind, for example, if I wanted to use the backlight with my loop leader, well, that is going to increase my voltage drop from around 1.5 volt drop to about 4.5 volts. And that's going to start causing me difficulty, because at 4.5 volts, now I've got 18, 22.5, and a little bit. I'm still under my 24, but I better make sure that I have a good 24 volt supply. If it's an unregulated or poorly regulated 24 volt supply and it starts dipping down, well, now I'm going to start running into my cap. But if I decided I wanted to add in another device, let's say I decided to add in a 2-wire chart recorder that dropped 5 volts, well, now you can see I've just got too much voltage drop in my loop, and now I'm going to start having issues with the loop just dropping out. It's going to drop out my 4 to 20. The current is going to go down to almost zero. My devices will all stop working, and that will be that. So it's really important to keep voltage drops in mind when you're ganging up multiple 2-wire loop-powered devices in one loop. Now, as I said, thankfully the loop leader only drops 1.5 volts without the backlight. And you can generally add a 1.5 volt meter into any 2-wire transmitter loop and be perfectly fine. So let's talk a little bit about how to choose the best meter for your application. You've seen a bit of the difference between 2-wire and 4-wire or loop-powered and line-powered devices, specifically panel meters. Let's talk about how you go about choosing the one for you. Well, one of the biggest considerations is the simplification of your wiring versus the ability to power the transmitter. With the loop-powered device here on the left, it's very, very easy to install. You just have one wire coming in, one wire going out. The loop power meter gets its power from the loop, so I don't have any kind of separate 24 volt or 120 volt input coming into it. It's just the milliamp signal. Now, compare that again to that 4-wire or line-powered meter on the right. Now I'm going to have AC power or second DC power supply coming in just to turn the meter on. However, by doing that, I now have the power needed to power my transmitter loop. And so what I'm doing here is I'm sacrificing, in the 2-wire or the loop-powered version, I've got a separate DC power supply or source that's needed to run the to run the transmitter loop. In the line-powered meter side, well, I have to provide 2 wires of power to this thing. However, I don't need that DC power supply. The ProView powers the output loop itself. So oftentimes it'll just come down to a question of which is an easier way for you to do your design. If you've got 120 volts coming into your panel, well, great. Use that to power up your ProView and eliminate the need for a separate DC supply. If you don't have that, or you've got an already existing 4 to 20 milliamp loop, you're looking to add a display to a loop that already exists, then going with the loop leader is often a great choice because it's so easy to install. So oftentimes what it comes down to is new installations, look at the ProView, take advantage of its onboard power supplies and all the features it can offer. Existing installations where you want to add displays to loops that already exist, use a loop power meter because it makes your life a lot easier. Now, it's worth spending a moment to talk about safe versus hazardous area applications. Very often, what I'm about to say are general statements. There are, of course, always exceptions. But generally, a loop-powered meter is going to be available with hazardous area approvals on some version of it. And that's because with so little power, it's relatively easy to design them to have non-incentive or intrinsically safe approvals. Because of that, you don't need to put them into explosion-proof boxes like you do line-powered meters in order to get those approvals. So it's a very different animal between a loop-powered meter and a line-powered meter the minute you want to get some kind of hazardous area marks on this product. So our loop-powered meters, like our loop leader, can be installed in both general purpose and hazardous areas. There's versions of both. Whereas your line-powered meters, without putting them inside explosion-proof boxes or buying the explosion-proof version, are only going to be safe area approved. And obviously, while you can go to that explosion-proof version, you're going to add a lot of cost to do that, whereas it's comparatively, it's a small price increase to get the approved version of a loop-powered product. So if you've got, for example, Class 1 Div 2 panels, or you are or have in your territory a Class 1 Div 2 panel shop, looking to loop power meters like the loop leader is a great way to fairly inexpensively get approved units into those panels. Whereas there's no good way to put a line-powered panel meter into those panels without some kind of additional protection methods. So if you know you want a panel meter that is relatively inexpensive considering the approvals it comes with, that's easy to install in panels, or you are or work with Class 1 Div 2 panel shops, especially UL panel shops, then I would look to a 2-wire loop-powered meter like our loop leader that's got UL and CUL marks for hazardous areas. It's ATEX and IECX approved, and it does Class 1 Div 1 and Class 1 Div 2 because it's both intrinsically safe and non-incendive. Another consideration is what you want your display to look like. Because the loop leader, because 2-wire or loop-powered devices generally use LCD displays, you can get a lot more custom characters on them. And what I mean by that is, you can see here, this loop leader has a top line with some decimal digits, a bottom line with digits that can be also units or tags. Now, even stopping there, you can see the difference, for example, between the ends. You have a much clearer display on that LCD. But now we've also got this percentage that's displaying in the upper right, which is relatively small and difficult to duplicate on something like the ProView on the bottom. And you've got this 20-segment bar graph here. So when I look at this meter on the top now, I know what my tank height is or my number of gallons is. I've got a label here to tell me what I'm looking at. I have a bar graph, so intuitively I just know where my level in this tank is going to be. I've got a percentage being displayed on there. That's a lot of information, and it's very clear and intuitive. Now you compare that with what you have on the ProView, and sure, I still got my 2 lines, so I still know I'm looking at 660.4, but it's a little less descriptive. It lacks the bar graph, it lacks the percentage. Another nice feature of the loop leader is because it has the ability to be backlit, we can make the entire display change color. On the ProView on the bottom, you've got red LEDs. That's what you have. On the top, you've got the ability to have a red flashing backlight in alarm conditions and a white backlight during normal operation. Of course, as we said earlier, the LED version on the bottom is better if you're viewing it throughout all lighting conditions. It's better if you want to be able to see it from wide viewing angles, or you want to be able to see it from a distance. So if display visibility is your concern, LEDs are a nice choice. Go with the line-powered meter. If getting a lot of really well-presented information is your concern, then go with the LCD because you have so much information on that display and it's so easy to read it. Now, a few other things that you should consider when you're comparing whether you want to pick a line-powered or a loop-powered device. So as we mentioned earlier, always consider the voltage drop in your loop-powered meters. You may find if you have enough devices in that loop that you simply don't have the choice. You don't have the voltage to run additional loop-powered devices. Now, if you've only got 1 or 2 things, and one of them happens to be something like our loop leader panel meter with that 1.5 volt drop, which is very low, you're probably going to be fine. If you start adding in other 2-wire devices, like your transmitters 2 wires, the loop leaders 2 wires, and then you start deciding you want to add in a chart recorder or a second meter, now you need to start counting those voltage drops. Real quick, one question that I had in here from Matt was, how do I know the voltage drop of my 2-wire devices? And the answer to that is you look in the specifications. So if you find yourself putting together a loop that's got 3, 4 loop-powered devices in it, look up those data sheets, check what the specs say, and just do the addition on what your voltage drop is. If it's a 24-volt supply, you want to make sure you leave yourself at least a 10% headroom, but other than that, use the 24 volts. You also want to take into consideration your front panel. You want to make sure that you've got a meter that's mounted in an industrial application. It's got an appropriate front seal. There's a lot of really low-cost 2-wire or loop-powered panel meters out there that don't have NEMA 4X fronts, that aren't IP65, that don't have UL Type 4X approvals. You want to make sure you've got one that's suitable for your environment. So if you happen to see a really low-cost loop-powered panel meter out there, make sure it's got the environmental seals that you're going to need for panels that are going to be outdoors or going to get washed down or could potentially have water falling on them. Operating temperature range is another critical issue with loop-powered meters. Because they have LCDs in them, those LCDs have a tendency to freeze and stop working once you get below 0. Now, Precision Digital's loop-powered meters are designed for these kinds of environments. So our loop leader goes down to -40, keeps updating, keeps the information on the display. But that is rare out there. Most meters only spec themselves down to 0, maybe -10, maybe -20. But you don't see them out there at -40. So if you're in a cold weather environment, be very aware of what that low temperature range is anytime you're working with any device that has an LCD on it, but specifically with loop-powered meters because they're not going to self-heat at all. Programming is another thing to consider. Many loop-powered meters that are out there have potentiometers on them, those little resistors that you spin with a small screwdriver. That's okay for simple meters. Even Precision Digital has some meters that have that option if you like to program your scaling like that. However, as you add more features in, you're going to want to look for something that has programming software, at least has front panel push buttons, because you're not going to want to be programming up something with 8 dip switches and 5 potentiometers. So you look at Precision Digital's new loop leader, it's got the 4 front panel push buttons, but it also has USB capability, so you can download some programming software, connect up your meter, and program it on the PC. Alarming is something that you need to consider. Most loop-powered devices don't have much in the way of indication or relays to let you know if you've got, say, a high level or a low level, or to do any kind of pump control. Again, Precision Digital's loop leader panel meter is an exception to that. We've got the ability to turn our backlight red in the case of an alarm because you've got a multicolored backlight. In addition, you can get solid-state relays on our product. So you can use those relays to send signals to other devices, to trigger intermediary relays, to turn on pumps, to have sirens or horns or light stacks. In fact, the loop leader can even have a 4 to 20 milliamp output and act as a signal isolator if you want to send that 4 to 20 milliamp with isolation off to another device so that it can do some controlling and monitoring. And as we mentioned earlier, we've got Div 2 approvals. So anytime you know that you're in a Division 2 area, which is the most common hazardous area that you see these installed in, going with a loop-powered meter is a great consideration because it's going to save you a whole lot of hassle and cost. So there's plenty of reasons why you'd want to use loop-powered meters. For example, the Div 2 approvals. However, you're also going to want to keep in mind what you need to know when you're selecting your loop-powered meters. Is the voltage drop low enough? Does it have the environmental and front field conditions I need? Is it going to be easy for me to program this device? And does it have the kinds of alarming features that I'm looking for? Now, obviously, I think in the case of Precision Digital, that's going to be yes. But when dealing with other loop-powered panel meters or devices, keep those in mind. And so I've been talking a little bit here and there about Precision Digital's Loop Leader series and some of the unique features of that. It's probably worth taking one moment just to look at those. So here you've got that picture of our loop-powered Loop Leader series panel meter again. Of course, what's going to jump out is the fact that we are not a simple 4-digit 2-wire meter. We've got a 5-digit upper display with large digits that are really easy to read. We've got a lower display that can show you a unit or tag and has 14 segments on it. So remember, for example, I've got the ability to show this G very clearly with that little notch in the G. And you've seen, for example, how tank looks on a 7-segment display versus a 14-segment display earlier. I've got the ability to see percentage above my bar graph. So I've got both a percentage display and a bar graph display. And so there is just a lot of information that is packed in there. You've got that 4 front panel push buttons I was talking about earlier to make programming easier. But we've also got a USB port for software for programming it. We talked about the cost of loop-powered devices. Well, these start at $204, and they're in stock. So when pricing is a concern and availability is a concern, going with a loop leader is a great choice for your application. Of course, it's a 4 to 20 milliamp input device, and it drops 1.5 volts on the loop. We talked about the red backlight and the ability to get that watertight NEMA 4X seal on the front. Again, -40 is something to keep in mind whenever you're talking about 2-wire devices in a Cold weather environment, our LCDs go down to minus 40. Why do ours go down to minus 40 and no one else's does? Well, because we work harder at it. We work with an LCD manufacturer that makes us custom displays, and we've been doing this for years. So we make sure our displays work down that low. The programming software for this is free, and you can download it at our website, predig.com. We talked about all the different outputs you can get in the loop leader, which make it a very unique product. This is not a simple two-wire device. Though it can be a nice, low-cost, simple display with two wires, if you like the advantages of it and you want to have it with solid-state relays or with a 4 to 20 milliamp output, you can certainly get it with those options. And speaking earlier of the industrial environment, how you want to make sure your meters are prepared for that, all of the loop leader printed circuit boards inside this case are conformally coated against humidity and corrosion that can come in and be a big problem for two-wire meters. With the amount of power these are using, small amounts of corrosion or contamination on the printed circuit boards can bring in humidity, can change really small resistances, and that can have a big impact on the display starting to jump or become inaccurate or lose its ability to turn on at certain milliamp values, etc. Because again, we're talking really low power inside of the unit. The power draw is very small. So to prevent any of those issues, Precision Digital goes the extra step of sealing all of our printed circuit boards to prevent that from becoming a problem. Now, if you need something that's good for hazardous areas, these are, again, great Div 2 panel choices. And you can see here we've got ATEX and IECEX approvals, UL and CUL for Class 1 Div 1, Class 1 Div 2, because we're both intrinsically safe and non-incendive. If you're using us in that non-incendive panel, you can most likely wire us up without any barriers. So if you like some of the features you heard about loop-powered meters, you like the simplicity of installation, you like the look of the display, going with the loop leader is your best choice for an industrial loop-powered panel meter. And with that, I'm going to see if we've got some other questions. It looks like we've got two good ones we can address here. So Mark was wondering, what's the average voltage drop from a loop-powered meter? Well, that's a great question. I talk about the loop leader, and it's 1.5 volt drop. The last generation of the loop leader had just over a 3 volt drop, and even that was low by comparison to some of the competition out there. You will find that there are loop-powered panel meters that don't seem to be anything special, but they might have voltage drops at 4 or 5 volts, and that's without backlight. So though with the loop leader's 1.5 volt drop, you often don't have to worry too much about the total voltage drop in the loop if you only have two loop-powered devices, say your transmitter and the loop leader. I would suggest when using other two-wire devices, you definitely count those voltage drops and keep it in mind, because 1.5 volts is a very low voltage drop, and I just wouldn't take it for granted with all two-wire devices. And then I've got a question from Thomas, who is asking about the solid-state relays and what exactly we mean by that. Well, what we mean by solid-state relays is that these are relays that don't have moving parts. They function exactly like the relays that people are traditionally used to, or what we call electromechanical relays. However, rather than having a magnetic coil in there and pulling a switch closed with that, it uses transistors and MOSFETs and chip-level board design elements to essentially do the same role of being a dry contact switch. It just happens to have no moving parts and be made up of electrical components rather than coils and magnets. So anything that you would do with a line-powered meter's electromechanical relays, well, you can do that with the loop leader's solid-state relays. They function exactly the same. They can push an amp of current through them, so they're pretty significant relays. They just happen to be solid-state. So it looks like that's all the questions we have that I can address for the moment. Joe, I just saw your question come through. Those are 1 amp that we can push to those solid-state relays. I don't know if you caught that, but so you can drive things with those versus, say, a transistor output or a open collector output that you generally only use for small signals, like sending a trip signal to a PLC. With the relays, you can put an amp through them, so there is a lot you can do with that. There are a few other questions out there that I think will be in touch with you after the webinar to discuss specific applications, etc. So I'd like to thank you for joining us. If you'd like to learn more, I would direct you to our webpage where you can look up other webinars we had. We have webinars there, for example, that describe what the difference is between 2, 3, and 4 wire connections and what all those connections mean. We've got webinars that go over the fundamentals of 4 to 20 milliamps that go much more into technical detail about voltage drops and how you calculate all of that and how current flows. You can, of course, call us anytime with any applications you have or send us an email if you prefer. And you can find information about those other webinars as well as the Loop Leader line of loop-powered panel meters at our website, www.predig.com. If you'd prefer, you can also reach out to me directly, and I'll share my contact information here on the screen and leave this up for you for a few minutes. I'd like to thank you for attending and remind you there is a survey at the end of the webinar, and I'd appreciate it if you'd take a moment and fill that out when you're done. I hope all of you have a good rest of your day and you find some great applications for loop-powered meters and line-powered meters, hopefully from both the Loop Leader loop-powered panel meter series and our ProView line-powered panel meter series. Again, if you've got any questions, we look forward to talking to you. Thanks.